Is it audible? 55 number. Hello. Hello, is it audible? 55 number. Hello. Hello, 55 number, are you there? Hello, is it audible? Hello, is it audible?
Yes, sir.
Okay, so we just wait for 5 more minutes so other can join us and then we will start, right?
Yes, sir.
Okay, so today we are especially going to start. We have already started the MATLAB session, and most of the experiments are simulation-based experiment. And the basic tools that we are using throughout the semester is MATLAB as well as LabVIEW. So, looking to that, we have started the introductory sessions of the MATLAB session last time, and continuing the same thing today. I will give you some more brief about the MATLAB toolbox, right? So last time we have discussed about the important function regarding linear algebra, how to create a matrix, how to perform the various operation between the matrix, and then we have even look around the various operations to extract the particular elements from the matrix. That part we have already done. Then I have given you a one examples how to make a file, how to create your own file as a .m extension. With the .m extension, what are the precautions that you have to take whenever you are giving the name of your file, that the name of your file should not be exactly similar of the command which is available in the MATLAB toolbox, as well as you cannot put some space in your name. The name should be in continuous fashion, and you cannot start any file name with any number and all these things, right? So all these parts we have already discussed. And even I think we have plotted one sinusoidal function last time. So plotting tool I have described, in which we have generated the time vector, and we have plot the sinusoidal function using a plot function, right? So this part I think already done. So today, now we will discuss about the various properties of the plotting function and how to plot the various function like using a subplot function, hold on function. Second year. Second year. And even we will discuss about the looping operations in a MATLAB, like as a for loop and while loop, etc. We will even look around some conditional statement like as a else, if else, how they can be utilized. And then lastly, if the time permits us, then we will describe, I will describe you about some function, how if your program is so long and you want to break down your programs in multiple parts, so how we can do this thing by using a some function, by using a function, right? You can make a one file is known as a function file and all. So this parts that we are going to learn, and especially today, we are going to start about some plotting. We will just learn about the some plotting tool. Uh, One plotting tool we have already learned about is the plot function, and now today we'll discuss in more detail regarding this plot function, right? Okay, so I think it's audible and it's visible too. Now I'm going to share my screen with you, and once the screen is visible to you, you just give me the response that the screen is visible, so we will move forward. Is this screen is visible to you?
Yes, sir, it is visible.
Okay, okay. So now I make the new file. Now the new file is visible to you. I writing the CLC command and all.
Yes, sir.
Okay, so now this is a file in which we will just learn about the various toolbox, right? Various toolbox. Now the thing is that suppose if you are not aware about the some command of a MATLAB and that you want to learn it more, you want to explore it more. So there is a help function in a MATLAB. In a help, you can type the command name and all the helps will be open for you. I will show you the demo of this one, but first of all, we just uh, go with the similar exercise that we have done last time. So we can plot the sinusoidal function. So for that one we have described, we can start with some vector. Vector will be start from 0, and we will take the step size of a 0.1. Means every time it take a step size of 0.1 to move forward, starting from 0, then 0.1, 0.2, 0.3, up to the last point is supposed to 5, right? And here, for this one, we are assuming the frequency of the signal is some like as a 10, right? You can say the frequency is a 10. Now I write this command to plot the sinusoidal signal. So the sines function will create a this is a function of t, right? F into t, we can say. Right? It is a frequency multiply with the time domain. So it's actually sine omega t, but the 2 pi will be multiplied automatically. So this s just hold all the amplitude values of your sinusoidal function. And now we use this plot function. This plot function have two important arguments. The one is the x-axis vector and another is one is a y-axis vector, right? So x-axis vector is a t and y-axis vector is a s, right? So after doing this one, we have to store this program somewhere. So I use this and whenever we are going to store this program, they will ask the name. So we can give the name as experiment one. Okay. I will share somewhere here in the desktop, so we can have a program of experiment one. Now I run this command. They will ask change the folder or add to the path. Change the folder means you want to store in the same folder, or if you want to change the folder, use the change the folder, so it will be aligned with your MATLAB, or you can add to the path. Right? Both are valid. So after running this command, I will even return back to my command window. So you are getting this graph, right? This is not a perfectly sinusoidal. Now if we figure out what is the reason why this will not perfectly sinusoidal, so basically MATLAB plot will join the two neighboring point. So s0 is here, and if there is a point 1, so at point 1 some point will be here, so it join down these 2 points, right? So if more and more points are there in a x-axis or the vector time vector, then we can have a better and better graph is there. We have taken very few points over here. We have taken the step size is a 0.1. So, and it's up to 2 pi. So up to 2 pi means 6.28. So we have only 62 points over there, right? And the 62 points are not that much higher. So if you want to improve the performance of the system, that is better, rather than 0.1 here, we put 0.01. So it means the step size is now reduced from 0.01. So we can have a more number of points within the same time duration. So if I run this program, so now you are getting the better graph, right? So this is the sinusoidal signal with how many cycles are there. So we have considered the frequency f is equal to 10. So it has a 10 cycle. So this is cycle number 1, 2, 3, 4. You can count the cycles. So there are 10 cycles are there, and the step size is 0.01. So for every value of time vector t, it finds the amplitude, and this all value of amplitudes are stored in a S, right? So the number of elements in a time axis t and the number of elements in amplitude which holds by the variable S, they are same. They are same in number. So if you plot this graph look like this way. Now, there may be some properties that we need to mention, that here it is not clear what is the x-axis value and what is the amplitude, what is the y-axis, right? So we need to mention that x-axis is the time duration and y is represent the amplitude. So to make this thing, that we have a one command is known as the x label command, right? X label. So here I add this command, and this command is always written or generally written after the plot function. So I write here is x label, and inside the x label there is a bracket. In this bracket, in a single quotation mark, we write the title of x labeling, or x labeling title, right? X labeling title, we can simply wait. So this X labeling title, we just put in a single quotation mark, and this is the time, right? This is the time. And what is the Y label? So this Y label, we give some name as a amplitude. So in the single quotation mark, everything is written in a single quotation mark. So whatever we write in a single quotation mark, that is just printed on a X axis and Y axis, right? Then we need to give the title of this graph also. So there is a command known as a title. This title will be printed on the top of the graph, and whatever we write in a single quotation mark, that will be printed on the top of the graph. So we give the generalized title. So this is a sinusoidal waveform. So we can say it is a sinusoidal wave. Right. This way we write the title. Right. Okay. Then we run this command. So after run this command, how this graph will be looks, just wait, it will be appear over here. Okay, is this graph is visible to you?
No, sir.
No.
Yes, sir. Yes, sir.
Yes, okay, it's fine. So now what is printed on this x-axis? There is a time, right? And what is the printed on y-axis? The amplitude. And what is the printed as a title?
There
So
is
that is a
time.
sinusoidal. There is a sinusoidal, yeah, time on x-axis, y-axis amplitude, and title is a sinusoidal wave. Now, the question is that can we change the line size of a line? Yes, it is also possible. Can you change the line, the type of a lines? That is also possible. And even we can give the color. We can change the color of line. That is also possible. So I give you one example in which we will see how we can change this property of this signal, right? So here we can say here this plot t comma s. I think it's now we came back to the main screen in which we have written the programs. It is visible to you, and now I type in here t comma s. By default, the color taken by the MATLAB for to plot any function is a blue by default, but we can make the change over here. Especially whenever we are drawing the multiple graphs over there, then we need to differentiate the graph, right? One may be a sinusoidal wave, another may be a cosine wave. So we need to differentiate the graph by some color, and then it is very essential that we use the different color for a different graph. I will show you that today also. So this t comma s, and then here I write in a single quotation mark red, right? R just for red. So every different color has a one symbol are used, one first letters are used. For a cyan color we use the C, for a blue color we are using the B, for red color we are using R, etc. Now I again run this command. So you notice what the change has been made in a graph. the color of the graph has been changed, right? And we changed from blue to red. I think it's visible to you, right? Okay. Now, along with this one, sometimes it does happens that you want to print the multiple graphs on the same window, and if your x-axis is the same, right? X-axis is the same, and that it is a very fine that you can use the multiple graph. Okay, so now I use this thing. If you want to plot the second graph on this first graph, then it will be overwrite, right? So it is essential that whenever we are plotting a multiple graph using the same window, then we use the hold on function. Hold on function means the first graphs will not be vanished or not be overwhelmed by the second graph. It will hold on the screen, and then on this screen we are plotting the second graph, that it is still hold on, and we are plotting the third graph. So if we want to place the multiple graphs on the same window, we use the hold on function. So now I plot the different graph. So I, let's say this graph variable, I consider the name is S1. That is also S1. Everywhere I have to change is S1. Now I want to plot the second graph, and the second graph is a cos, right? I want to place the same frequency and same time duration, I mean same time vector for all these points where we have plotted the sine function. For the same time axis points, I want to plot the cosine graph. So nothing is changed, only the function is changed from sine to cos. So it can be represented as a cos multiply with a t, and that is stored in the which holds the variable which hold these all values of amplitude is known as a S2. Now I want to plot this graph, right? So what we can do here, the first graph we have already plot, and before we plot the second graph, we have to put somewhere hold on function, right? Hold on means the first graph is not be overwhelmed, or it not be overwhelmed by the second graph, right? So we are using the S2 as a cos f into t. Now we use the plot function, and inside a plot function we will use the t comma s2, because now our variable is changed from s1 to s2. S1 holds the value of sine signal, sine amplitude of the sine function, and s2 just hold the amplitude values of a cosine function. So now we want to plot this, and if I use this one, and so you can see yeah, is this window is visible to you? Hello?
Yes, sir, it is visible.
Okay, so you, what you see over here, you see the two graphs simultaneously,
Blue
right?
and red.
Yes, one is the blue and another is red. So
Yes,
red
sir.
color we have defined for a sine function, so that is a sinusoidal graph, and the blue color we have defined for a cosine
Cosine.
signal, so that shows the cosine signal, right? So we can have a two graphs over here. One is a sinusoidal graph, and the second one is a cosine graph. Now the thing is that we need to differentiate this, because we know this function is for sine and cosine. But once anybody if read your graph, they should be identify which graph is which color or which line styles are used for a which graph. So here we need to define is using a legend function, right? So here we are using the legend. A legend function is to differentiate, to give the title of a graph. We have already given a title. This is uniform title for whole graph. But if there are multiple lines are there, multiple plots are there, so plot wise we need to give a title. So here the legend function is there. The first graph is it always give the title in a sequence. So first graph plotted, it is the name should be matched with the first graph. So first graph we have plotted is a sinusoidal sine function. So we give the title as a legend. Inside a legend, inside a bracket, we write the sine function in inverted comma. This is the title of your first plotting graph. Now the second plotting is a cosine. So here inside a single quotation mark, we will write a cosine, right? Okay. Then I run this command. After run this command, you can notice whatever the change has been observed on the graph. In the upper right corner, you can see that shows the two titles, sine and cosine. The sine is shown by the red line. It means whatever the graph here which is plotted with the red line, that is sine. Is it visible? I think both are okay. I have to make run once again.
Yeah, both are red.
Yeah, okay. Now you can observe this graph. So we can see one mistakes we have made is we have to put the hold off at the last, right? We have not I just to show you, but this graph shows there are two graphs are on the screen. The first graph is just a sinusoidal function. You can see in the upper right corner, it's a red color graph, right? Red color graph is a sine function, and you can see the blue color graph is a cosine function. Okay, so that you can see over here. Now there is so here we have to use the hold on function. Hold on function. Sorry, hold off, because we have used already hold on. So here we use the hold off. Okay, so then whenever you run every time, so your previous output will not be affected, your new output. Otherwise, what happens? Your previous output is still hold on, and you plot the new function, so there is again hold on. So if you are not using the hold off function, so all your previous outputs are every time available with the new output. So they will be mixed up together. Now, sometimes this is okay, this is fine, but sometimes the values of x-axis are not same, right? The values of x-axis are not same, they have a different values. So for that one you are not using the hold on function to plot this one.
Sir,
Hold on, 1 minute. Yes,
sir,
yes.
sir, can you explain that line 3? I didn't get line 3 on the program.
1 minute, just wait, I am busy somewhere.
Okay.
Okay, so I again share my screen with you. I was busy with some. Yes, what is your problem? What you want to understand?
Sir, on
Hello.
line 3 where there is t equals to 0, then 0.012, I don't get those values, what they mean.
Acha, you are parallelly doing this?
Yes, sir.
Okay, so what this, you are not understanding this 0, 0.1 up to 2 pi?
Yes, sir.
Okay. So what actually, if you run this one, it means the 0 is the starting point of time axis, right? And 0.01 is a step. And what is the 2 pi? It's a 2 pi means the last point. So if you run this command in a command window, so it basically print this thing. It is starting point, then it create a vector starting with 0. Then what is the step size? 0.01. So next iteration would be a 0.01. Next iteration would be 0.02, 0.03, like this, right? Up to how many points they will create? The last point would be a 6.279, because okay, 6.280, right? Like this. So they will create these all points. It's a create a vector of this one, right? Is it clear now? So zero
Yes.
indications the starting point from where the vector start. 0.01 is the step size. So the first step is 0.01 in a 0. Added 0 with 0.01. So it is 0.01. Then 0.01 is again added. So it becomes a 0.02. Then again 0.01. So every time 0.01 is added in the previous value, and you are getting the new value, right? And what will be the next value here? 0.04. Up to here,
2.04.
all the points where you have to stop, it's a 2 pi. 2 pi means 2 into 3.14. So it is exactly 6.28,
Okay,
right?
sir.
So whenever the 6.28 comes, this vector will stop. So it will be create a vector for all the values of time axis starting from 0 to 6.28 with a step size of 0.0. Is it clear now?
Yes, sir, it is clear.
Okay, fine.
Thank you, sir.
Okay. So for all this value, we are plotting the sine function, right? All this value we are, so this is x-axis value, and for all this x value here, we are putting this t over here in S1. So all this value, it creates the amplitude values, and this amplitude values are stored in S1 y-axis value, and then we plot t versus t comma S1 means the time axis on a, and S1 means the amplitude on y-axis, right? Okay, right. Okay. So now the thing is that this is way how you plot the function, right? How you using a plot, you can plot the various function using a plot toolbox. Now the thing is that suppose you have a different sine and cosine which don't have a same value of this one, right? Which don't have a same value of this. One will be plotted for a 2 cycles, or may have a different frequency. One have a frequency of 10 hertz, the another has a frequency of 20 hertz, and etc. So in that case we use the subplot function. So in a subplot function, what happens in the plot function, you have seen, if I run this one, so you have seen in the same graph, in the same display or window, we have a two graph. One is the sinusoidal one, and the second one is a cosine view, right? But this is applicable only whenever you have a same value of time axis, means same time vector for to plot the both the signal. But if you don't have a different sine waveform, or you want to watch this graph separately, then rather than this plot and hold on function, we are using the subplot, right? So what happens in subplot? So subplot means divide your screen, right? If it divides your screen in a multiple windows, your first one window of display, it will be divided in multiple windows, right? And it will be plot, if we give the location of this graph of a different window, then it will be plot on a different window. So it just break down your window in a different n number of windows, like as a 9 windows, 4 windows, 6 windows, like this. And for every window, every sub window, that is known as a sub window, and for every sub window you can place your one graph, right? And that is using a subplot function. So I will show you by using a subplot how we can do this one. So I just write here, this is my sinusoidal function, right? And I want to plot this, everything is fine, right? I don't require a hold on because I use the different split window, that is known as a split window. So in a split window, I just use, I have two graph only, right? So I want to divide my main window in only two sub window, So what we can do here, so there is a function, we have to before the plot function we have to define where we have to put this. So that is the command which is used for this function, is known as a subplot. So subplot is used actually to define the location, right, at which your graph will be plotted. So you define my screen as a 2 row and 1 column, so 2 comma 1, so 2 comma 1, it means 2 row and 1 column, right? So how it is divided the window? Horizontally it divide. It horizontally split the window in a two parts because it's a 2 row, and column is a single, so it will be not divided vertically but horizontally divided in two parts. Then, so how many places are created? Two places are created. If you divide your window horizontally in a two parts, so you have two places, the upper places and the lower places, right? So the upper places is known as a first places. So the third argument is for a place. The first two arguments are used how many rows and columns you divide your window. So the first defines the number of rows. So there are 2 rows you divide your window, and the second argument defines the how many columns along which you divide your window. So that is one, and the third will defines at which place of this of this you are putting your plot function. So you can have a 2 comma 1 comma 1. It means you divide your whole window or split your window in a 2 row and 1 column, and on the first place you put this graph. The same way for here, but here this the first two arguments are remain same. You divide, you have already divided your window in 2 row and 1 column, but now you plot this cosine function on a second place. So that is a second place. So this one defines the place number, right? This one will define a place number, right? Okay, so now I run this command. So you see, you notice the different, see, X label, Y label and title. So we need to repeat every time, so because now we have a different sub window. So for every sub window we need to repeat this one, right? Legend is not required because we are not plotting a multiple graph on the same window. We are plotting a different graph on the same window. So now I run this command. So after running this command, you observe there are some errors has been occurred. I need to replay. Okay, so rather than subplot, I written here sunplot. So that was the error. It's a subplot, right? Subplot is a command. So if I run this one, so after running this, what you observe? Uh, okay, is this visible to you? Hello?
No, sir.
No, you have not visible. This figure is not visible.
Yeah, it's not visible.
Okay. Now is it visible?
No, sir.
Okay, not visible. Okay, now is it visible?
Yes, sir.
Yes, sir.
So what you notice here, you have a two different window, right? The first window, so the total display you have divided in a two part, two row and one column. So two row and one column. If you take one paper and make as one square box and you divide them in a two row and one column. So where you split? You split horizontally, right? So horizontally, if you split in a two parts, so upper part and lower part. So upper part is known as a 2, 1, 1, right? And the lower part, bottom part is known as a 2, 1, 2. So this is the location identity. So on the first location identity, we have plotted the sine function. In the bottom location identity, we have plotted the cosine function. Now we will explore this topic further. Okay, now I came back to the original screen where the code is written. Okay, so now the thing is that suppose if you have a 9 functions are there, right? I'm not elaborate in this times all nine function, but let's say there are 9 functions are there because you want to have you have a 9 plots rather than 2 plots. You have a 9 plots, right? So can you tell how many window I need to create? 9 windows, right? So how you use this function? How many rows and how many columns we need to create a 9 sub window from a single window? Yes. Hello. Let's assume rather than this two plot, we have a 9 plots are there. I want to plot a 9 figures are there. Let's assume we have a 9 figures to plot. We have to place in the same figure, right? So how many rows and how many columns are required to generate a 9 places? Is it audible? Hello, hello. Is it audible? It's not audible. Is it
Sir,
audible?
you're audible, sir. No.
Okay. So I am the my question is you want to create a 9 places, right? So how many columns and how many rows you require? 3 row and 3 column, right? Because if you divide your screen in a 3 row and 3 columns, so how many places are created? 9 places are created, right? So consider like this way. Let's say you have this window, right? And you want to create a nine window out of this, right? So what you do, you can have a one horizontal line and second horizontal line, right? So how many places are created? 1, 2 and 3, right? Now you again divide with a 3 columns, 1, 2 and 3. So how many places? This is first window, second window, third window, right? 4, 5th, 6th. And similarly you have 7, 8 and 9. So how many rows and how many columns you have divided? Need to create a 9 places, 3 row and 3 column, right? So we can say this one we need to divide in a 3 row and 3 column, right? It's 3 row and 3 column, right? And so we have 9 places are there, and out of 9 places we want to put only 2 figure, right? So that is our choice. So how many places are created? 3 comma 3 comma 1, 3 comma 3 comma 2, 3 comma 3 comma 3, up to 3 comma 3 comma 9. So 9 places can be created, and out of 9 places you can place your figure anywhere. So let's say I put my place at the second position, and I put my this one is also 3 comma 3, but the last one is changed, the position is changed, is a fifth, right? So I run this one. So are you able to see the figure? Hello? Yes, right? So are you able to see the figure?
No, sir.
No. Okay, now are you able to see the figure? Right? So what you can say, you have a 2 figures are there. This figure is a 3 comma 3 comma 1. We have not placed anything over here. This is the place, it is 3 comma 3 comma 2, right? We have a sinusoidal figure over here. It is a place of 3 comma 3 comma 3, right? We don't have place anything over here. Then it is a place of a 3 comma 3 comma 4. We have not placed anything, but in 3 comma 3 comma 5 we have placed the cosine. So that is a place. Now here 3 comma 3 comma 6, right? And here 3 comma 3 comma 7, 3 comma 3 comma 8, and here we want to plot, we have 3 comma 3 comma 9, but here we have not placed anything on 3 comma 3 comma 7, 3 comma 3 comma 8 and 3 comma 3 comma 9. So this places or this spaces are left as a empty spaces, right? Is it clear? Okay, now you let me know with this figure, you let me know if I want to place uh, only 3 figure. One is the sine, another is a cosine, and the third one that I select as S3 is equal to sine plus cosine, right? So it is a sine of ft uh, plus a cos of ft that I want to place. And so this is the same. This one all these things are look same. So I control C and control V. This one is the plot. This is not required. S is the multiplication of sine and cos, addition of sine and cos. So that is S3. So I want to plot S3, right? All the things are same. Okay. Now my plan is I want to put all this figure diagonal in a diagonal of 3 row and 3 column places. So how I can place it diagonally? What is the location of this one? First figure, third figure, and what is the location? I have to put always subplot above the plot function, right? Everywhere. So what is the location if I want to put either right diagonally or left diagonally, right? But it should be appear only at diagonal position, only at the, it should be filled in diagonal position. So what is the subplot? What I have to write here? Anybody of you? How can I use the subplot function to put my figure diagonally only? Hello? No idea? No idea about this. Okay, so I have to place, it's a 3 comma 3 comma 1, right? The first position. Then what is the next diagonal position? 2, 3, 4, 5, right? So I have to push, this is a 5, this is fine. And what is my last figure I have to place? is 3 comma 3 comma 9, right? 3 comma 3 comma 9, and then I run this one. So then the final figure is appear. Where the final figure appear? Okay, again. Are you getting this? Every time it's leave the control. Okay. Hello, is it audible? Hello.
Yes, it's audible.
Okay, so now you are able to see this window.
Yes, the command window.
Okay, are you able to see the graph? Okay, so why? Are you able to see the figure? This figure?
No, still at the command window, sir.
Command window you are showing, right? Okay. Okay, now you are able to see this one.
Yes, sir. 4 graphs.
Okay. Whole graph. So you can see this is a sinusoidal function. This one. So what you observe here? There are three graphs are there. I think this have some. I made some mistakes. So this graph is appear. Otherwise, you can have three graphs, right? 3 comma 3 comma 1, 3 comma 3 comma 5, and 3 comma 3 comma 9. So that way you can using the subplot function. We can have a plot the various functions over there, right? So this is a one thing that we need to do. And okay, so I think it is sufficient for today, but there are some other functions that I would even would like to highlight in front of you is how to use some looping functions or how to use some if else statements and all. So I just came back to the main window screen, and in the main window we will see, let's say this is visible to you, editor and all. Hello.
Yeah, yes, it is
Yeah.
visible.
Okay, so this is a comment line. I means I have disabled this all the lines. If I run this one, so only CLC clear screen is it will be executed, but this all things will not be executed because I have made it disabled, right? So by using Control and R is a shortcut key to make the something disabled by using a comment line. Now let's consider you have a one number and you want to check whether the number is positive or not. So we are using if and else statement, and every looping this every conditional statement is to be ended by using a AND function. So there is no any curly bracket like as a what you are using in a C or C++. Like in C and C++, if a loop body, say you can start with the opening bracket and you complete the body with the closing bracket. But here there is nothing like this. In MATLAB, you have to you have to complete the body of or looping or whatever the condition which you have written in if and else statements by using an AND function. So the first thing is that we need to enter one number and we want to check whether the entered number is a positive or not. So you tell the user to input any number. So there is a one command known as input command, and inside input command you write the comments what you need to write. So the persons who is entering the number, you can identify. So you can say enter the number, right? And whatever the number has been entered by the user, so you have to print whether this number is positive number or not. So here there is a conditional looping conditional statements you need to require to check whether this number is positive number or not. So we will check how you will check whether the number is positive or not. We will compare with the, so every if loop we write with AND function, right? This is a body we have to write inside a body. So every conditional looping statement will require two things: what you write inside a body, and the first very important part is expression. So here you have to write the expression. So inside a bracket I write the expression as s is greater than 0, right? So what we need to print, so here there is a function known as a printf, or even you use the display function also. Both will do the same job. Either you use the display or this printf function. If s is greater than 0 means you need to print the number is a positive number. So you write the number is positive, right? But if s is not greater than 0, so you have two options: either the number is negative or the number is 0. So what you can write here, it's else if statement you are using, right? Or you simply write else you write the number which is written is 0 or negative, right? The number everything you write in a single quotation mark, and a number uh, is either 0 or negative, and you write this. Okay, now you complete this statement. So what this program will do, these programs will ask users to enter the number. So this is a command. So whatever the number has been asked by the to the use from the users, that will be stored in the variable s. Now you will check if the input number is greater than 0, so this will be executed. So this body will execute it, and where the number is positive, it will display on the screen, right? And then it will be ended over here. Else will not be executed. Either if will be executed or else will be executed. But if the number is not greater than 0, so it will be directly go in the body of else statement. And else statement, in the else statement we have written this one to print is that either the number is 0 or negative, right? Now we will check how it works. So I run this code, right? So command window. Now I will show you the command window. What is us? Okay, so in the command window is actually used to give the input function and to observe the output function. So here it is written enter the number, right? We need to enter the number. So we will check for two numbers. Number is negative, three numbers. One number is positive and 0. And for all these three, any random number, it works fine. It go in if and else statements. For every positive number, it prints the positive number, or for 0 and negative, it prints the negative. Then it means your program is working correctly. There is no any debugging is required. So I enter the number as a 4, right? And I enter this one. So it automatically print the number is positive. It means it correctly going in if statements and working fine. Now I again look back to give the different number. I again run this code. Sorry. I again go in this code and I again run this one, right? After running this, I came back to the command window. Sorry, I have came back to the command window, and we need to see what is again. They ask the number. Sorry. Okay, I run this one. Right. Okay. So is it visible? The screen is visible to you? Okay. So in the screen, they're asking to enter the number. If I give some negative number as a minus 25, so it will give the number is either 0 or negative. So this is the way how you can use the if and else statement, right? Okay. Now I return back to the same window. Okay. Now sometimes you want to differentiate between 0, positive and negative number. So here what you write, else if statement. In else if statement you have a different again condition, if else is less than 0, right? Then you can say the number is negative. Number is negative. So if statement will not be executed, it will be search to find else if, and if else if is even not executed, so then it will be go in else statement. So right, so it's known as a ladder of if else conditional statement. And then if the number is not a positive, if the number is not a negative, then so then it display the number is 0, right? This one is there. Now I run this command. Right, so it will be ask me to enter the number. If I enter 0, it will be display the number is 0. If I have entered the number is positive, it will display the number is positive. If I enter the negative, it display the number is negative. So this is a way how this function is basically work. Okay, is it clear? Is there any doubt here? So we will move further. Hello.
No doubt, sir.
Okay, so now I return back to the again main code where we have written the code. Now I will describe about the for loop and while loop, right? So for loop is basically used whenever you have to make some repetitive actions. I mean, something you want to add multiple times, something you want to multiply multiple times. So we are using a loop, and we can apply some expression or conditional till this expression does satisfy the program, the body inside a loop is executed. And once the condition doesn't satisfy for some variable values, then this loop will exist. So till that the loop will be rotate front and back, and whatever the body inside a loop is executed repetitively, and we are getting the output continuously. So for that one we have two loops. One loop is a for loop and another loop is a while loop. Let's say we want to add some number, add the number up to the number we are entering, right? So here we write enter the number, and we want to find so number should be added from 0 to that number, right? Like for example, if you add the 10 number, so we are interested to find the addition from 0 to 10 number. I mean 0, 1, 2. If we enter the 20 number, so we are interested to find to add all the numbers from 0 to 20, right? So this kind of a program we want to make. So enter the number, right? So we are using here control T. We will make everything, sorry, control R. So I just disable this one. Now I write the code using a for loop. So for loop, I have to define the variable which start to add from 1, right? It start to add from 1 until which number it has to add it. So it has to add from S. So I write here 1. It is the starting number. Then 1 is the step size. So next value of I is 2. Because step size is defined as a 1. So first number is 1. The next one is 2. Then 3, 4, like this, right? Then I write the S. S is the final number, right? Once it reaches to the final numbers, then it has to stop. So I have to write everything inside this body. This is link. So inside of I have defined the first expression over here. How many times this expression will define how many times the loop is to be executed. So loop is executed from all the numbers 1 to s. So if any I is taken the different value starting from 1, then it will be incremented every time with 1. So next time it will be 2, 3, 4 up to the s, right, till I will not reach the value of s. The body inside a for loop is executed. So what we do here, we will add all these numbers, right? So we use the dummy variable here, and the dummy variable we assign a 0. Right? Why we are using? Because every time the value of I is changing, so we have to hold those all the previous sum. So I am using the sum one. Why sum one? Because sum is already a command in a MATLAB, so I cannot reutilize it. So I am using the another variable known as the sum one. CD player झालं चालू? बघली गेली. कोणाમાં check? આમાં CD player જ ના આવે. બસ દિન તક બતાવगी. CD player જ નથી આમાં. હે? CD player ના આવે. So now we can say sum1 is equal to the previous value of sum1 and the new value of I, right? So what happens? Initially the sum1 is 0, so 0, inside is 0, the value of I1 is stored. So 1 plus 0, it will be held in 1. The next time when value the I has a value of 2, so it will be add in all the previous sum 1 plus 2 3 is again held in the same variable, right? 3 will be held in the same variable. So old value, this sum has present the old value, and after addition the new value are stored, which replace the old value in the sum1 variable. So sum1 has a 3 value. Now I will take the next value as a 3. So this 3 will be added with all the previous sum is already recorded over here as a 3 plus 3 6. So in consecutively this way it will be go. So sum1 hold the previous sum, all the sum of all the previous values you have already added earlier, and the new value of I will be added. Then a new value of sum1 is created. Now next time the whenever you recall the sum1, so it will reflect the old value of the sum, and then it will be added again with a new value of I. So consecutively I will be increased, and we are adding all these numbers from 1 to s, right? And then finally at the end of this for loop we need to display this value. So we are using display of s. So s will be added, right? Okay, now I am going to run this code. Is this command window is visible, right? So they are asking to enter the number. Let's enter the number as a 5. So what is the addition from 1 to 5? 1 plus 2 3, then 3 6, then 4 10, and then 5 15. So if I add, so it will give us a 15, right? Again I run this same code for some new value, let's say this times we give some value as a 10, right? So what is the addition of all the numbers up to 10? So that is 1 plus 2 plus 3 up to 10. So that is n into n minus 1 by 2. So 10 into 9, 90 by 2. So I think it may be a 45, right? Sorry. So that will be will executed up to s, and then sorry, display of someone, sorry, it's my mistake. We always display the someone, right? Okay, so now I enter this 10, and then it will be sorry for 55 number, yeah. So it's n into n plus 1 by 2. So 10 into 11 by 2. So it's a 55. So this is a way how the for loop is executed. So next time we will discuss about the other functions, like as a how while loop is executed. Then we will discuss about how the function is basically used to split out your main program with a different sub functions or sub programs, right? So this is a way we can concise our main program size. We can concise the main programs, executed it separately, and if error is occur in individual programs, so we can identify correctly and make it correct. So rather than 1000 lines program in a single files, we can have a split of we can split the programs in a 10 different files with 100 lines each, right? Okay, so I think that is remains for you to understand the MATLAB, and we will take one more session to understand it more deeply about some various functions like the while loop switch. Next time we will discuss about the while loop switch statement and subroutine, I mean sub function of this. Okay, is it fine? Hello.
Yes, sir, it is fine.
Okay, so now I leave the meeting. So have a nice time and good day to all of you.
Thank you, sir.